Hello everyone. In the previous class, we came to know about various definitions in vector analysis, definition of vectors, scalars, unit vectors, and few products, say dot product of two vectors, vector addition, and how could you find the values of a vector, etc. And today, now we'll come to know about how could we find the angle of a vector with the coordinate axis. And given an example, we have to find the angles which the vector A makes with the coordinate axis. At first, we have to late the angles that the vector A makes with the coordinate axis, which is alpha, beta, gamma. That means we have laid the vector A makes the angle alpha with x-axis, angle beta with y-axis, and angle gamma with z-axis. So here given the process, how could we find the angle of a vector with a coordinate axis? We know along x-axis, the unit vector I acts, along y-axis, the unit vector j, and along z-axis, the unit vector k acts. And here given the dot product of the vector A and the unit vector I, which acts along x-axis, and according to a dot product rules, where we can write this the uh, magnitude of the vector A dot magnitude of the vector unit vector I, which is 1, and cosine of the angle between these two vectors, which is alpha, cos alpha. And the value of A, we can write this. The vector is defined by this in the question. We can write this value as root over 3 square plus minus 6 whole square plus 4 square. And after simplification, we get 49 and root 49, which is 7. Again, we can do the dot product directly, the vector A and the unit vector I, and vector A, which is this, which is given in the quotient 3i minus 6j plus 2k, and unit vector I. And after dot product, we get 3 into I dot I, that is 1, 3 into 1, 3. And for the other vectors, say j dot I, which is 0, k dot I, which is also 0. And so we can put these value 3 here, a dot I, which is 3, and we get cos alpha equal to a dot I by 7, that means 3 by 7. And using calculator, we can write this term equal to 0.4286, and from which we can easily find the angle alpha, which is alpha equal to cos inverse this, and using calculator we get approximately 64.6 degree. Similarly, we can find cos beta and cos gamma, hence the angle beta and gamma. Here given a note, the cosine of angle alpha, beta, and gamma are called the direction cosines of A. So next topic here, given scalar or dot product of two vectors that we already came to know in the previous class. The scalar or dot product of two vectors A and B is defined to be magnitude of A into magnitude of B cos theta, which is scalar, where theta is the angle between A and B. Here given the geometry along OA, the vector A is acting, and along OB the vector Bx, and the theta is from A to B. And the formula is A dot B equal to AB cos theta. And in the previous class, we proved that the dot product is commutative. That means if we alter their position, we get the same result. That means A dot B equal to B dot A. Here given the geometrical interpretation of the dot product, the scalar product of two vectors is the product of one vector, and the angle of the projection of the and the length of the projection of the other in the direction of the first. That means the geometrical interpretation of dot product is the product of one vector and the length of the projection of the other vector in the direction of first. That means if we let OA is a vector A and OB is a vector B, then according to the rules of dot product, we can write A dot B equal to the magnitude of OA into magnitude of the vector OB and the cosine of the angle theta in between the two vectors cos theta. And according to the rules of cos theta, we know cos theta equal to base by hypotenuse. That means Bhumi by Otibhuj, ON by OB. And after simplification, OB cancel, we get OA into ON. OA, which is the length of the vector A, and ON, which is the projection of the vector B along the vector A. This. Here given an application of find the projection of the vector A on the vector B. So we have to find the unit vector of the vector B because we have to find the projection of the vector A on the vector B, and that's why we have to find the unit vector on the vector B, which is B cap, B vector B by magnitude of vector B. So which is this vector B, which is I minus vector B, which is 4i minus 4j plus 7k, and the magnitude of this vector, which is 4 square plus minus 4 whole square plus 7 square. And after calculation, we get root over 81, that means 9. And further simplification, we get 4 by 9i minus 4 by 9j plus 7 by 9k. So the projection of the vector A on the vector B, which will be the product of the vector A and the unit vector B cap. This projection of vector A on the vector B, which is A vector dot unit vector of B vector. So A vector in the question, which is given I minus 2ij plus k, and the unit vector B cap, which is this. And after simplification, we get 19 by 9. Here given two nodes, I dot I, which is this, magnitude of I in the cos 0, which is 1, and the magnitude of the unit vector, which is 1, that we know, and the dot product of I dot j, unit vector I, its magnitude, and the magnitude of the vector j, and cos 90 degree, because I acts along x-axis and j acts along y-axis, and the in between angle is 90 degree, and we know cos 90 degree is 0. That's why ultimately we get 0. Here given the definition of cross or vector product, the cross or vector product of A and B is a vector A cross B, which is denoted by C. The magnitude of A cross B is defined as the product of the magnitudes of A and B and the sign of the angle theta between them. The direction of the vector A cross B is perpendicular to the plane of A and B such that A, B, and C form a right-handed system. In symbols, A cross B equal to magnitude of A into magnitude of B sine theta dot u cap, where the range of theta is greater than 0 less than pi, and u cap is a unit vector indicating the direction of A cross B. That means the direction of A cross B is perpendicular to a plane which contains the vector A and B. Here given two nodes, if the vector A equal to the vector B, that means if A and B are parallel, in that case the angle 0 and we get sine theta 0, and that's why from this formula we get A cross B equal to 0 vector. And we can evaluate the cross product through the determinant. If the vector A, which is a1i plus a2j plus a3k, and the vector B is defined by b1i plus b2j plus b3k, and finally we can evaluate these cross product through this determinant. Here given an application, determine a unit vector perpendicular to the plane of A and B. That means we have to find a unit vector. We have to find a vector which is perpendicular to a plane. That plane contains the vector A and B. That's why we have to find A cross B, and finally we have to find the unit vector of A cross B to get the solution. So at first, A cross B. Uh, we already came to know how could we evaluate the cross product through the determinant. So I, j, k, the vector A, whose elements 2, minus 6, minus 3, and the elements of vector B, 4, 3, minus 1. And after simplification, we get 59 minus 10j plus 30k. Now the unit vector of A cross B, we know A cross B by its magnitude. So 59 minus 10j plus 30k, and its magnitude is this: 15 square plus minus 10 whole square plus 30 whole square. And after simplification, finally we get 3 by 7i minus 2 by 7j plus 6 by 7k. So this is one of the vector, and we know there is an opposite direction. Uh, this vector is perpendicular to the plane of A and B. So there is an opposite direction, and to get that direction, we just have to multiply this vector by the negative sign. And another unit vector opposite in direction is minus 3 by 7i plus 2 by 7j minus 6 by 7k. So it was our today's topics. Okay, that's all. Thank you.